Have you ever wondered if time, as we perceive it, is a universal truth? Let's delve into the enigmatic concept of time, a phenomenon that governs our lives, yet remains a mystery. Time, you see, is relative. It's not an absolute quantity that ticks away uniformly for everyone and everything. Instead, it bends, stretches, and contracts, influenced by gravity and velocity. Yes, you heard that right. Just as a rubber band can stretch and shrink, so can time. This is a fundamental aspect of what we call the theory of relativity, a concept that revolutionized our understanding of time and space. But let's not get ahead of ourselves. Let's first consider how time is perceived across different cultures. To some, time is linear, moving from the past through the present and into the future. This is the perception most of us are familiar with. But to others, like the Aymara people of South America, time is seen in the opposite direction, with the past ahead and the future behind. In some Aboriginal cultures of Australia, time is circular, with events and experiences repeating in cycles. There's also the concept of polychronic time in many African cultures, where multiple tasks can be done at different times simultaneously. These varied perceptions challenge our conventional understanding of time as a strictly linear entity. Now, let's touch upon the head-spinning concept of time dilation in physics. Imagine you're on a spaceship traveling close to the speed of light. Time for you would pass slower compared to someone stationary on Earth. So, if you embarked on a 5-year space journey at light speed, you'd return to find Earth aged by several decades while you've aged only 5 years. This isn't a Hollywood fiction, but a scientific fact, a consequence of Einstein's theory of relativity. So we see that time is not as straightforward as we think it is. It's a fluid, relative, and deeply fascinating concept that continues to challenge our understanding and perception. And this is just the beginning. Hold on to your seats as we journey further into the enigma of time. Now let me share some facts about time that might surprise you. Have you ever experienced a moment of extreme danger where time seemed to slow down? Perhaps you've been in a car accident, or you narrowly avoided one, and for a split second everything seemed to move in slow motion. This isn't just your imagination playing tricks on you. Science has a fascinating explanation for this phenomenon. Research suggests that during life-threatening situations, our perception of time slows down due to a surge in adrenaline and heightened awareness. It's as if the brain switches into high gear, capturing and processing information at a faster rate than usual. This rapid intake of information makes everything appear to slow down. It's like your brain becomes a high-speed camera, recording every detail with extraordinary precision. Surprisingly, this isn't the only situation where time can act in strange ways. Have you ever heard the phrase, "time flies when you're having fun"? Well, how about time slows when you're in space? Yes, you heard that right. Astronauts age slower in space compared to people on Earth. This isn't a result of a healthier diet or a rigorous exercise routine on the International Space Station. It's because of the effects of gravity on time, a concept rooted in Einstein's theory of relativity. You see, Albert Einstein, one of the greatest minds in the history of science, proposed that time and space are intertwined in a 4-dimensional fabric called space-time. According to his theory, massive objects like Earth distort this fabric, creating a sort of well that objects fall into, which we experience as gravity. But here's where it gets really interesting. This gravitational well also affects time. The closer you are to the source of the gravity, the slower time flows. This effect, known as gravitational time dilation, means that time passes slightly slower for someone standing on Earth's surface compared to someone in a spaceship far away from any massive object. The difference is minuscule, but it's measurable. So astronauts in space, being further from the Earth's gravitational well, experience time at a slightly faster rate. In other words, they age slower than us Earthlings. This isn't science fiction, folks, it's science fact, confirmed by precise atomic clock experiments. Now, before you start packing your bags for a journey to space to gain a few extra seconds of life, consider this. The effect is so small that after spending a whole year in space, you would age only about 1 millisecond less than someone who stayed on Earth. So, perhaps it's not the most practical anti-aging solution. Isn't it fascinating how time can behave so differently under various conditions? Time, as it turns out, can also play tricks on our minds. Ever glanced at a clock and thought that the second hand seemed to pause just a moment longer than it should? Well, you're not alone. This is a common phenomenon known as the stopped clock illusion, and it's a perfect example of how our perception of time can be distorted. Imagine you're in a bustling city, and you look up at a towering clock. The second hand seems to hang in the air, defying the laws of time before jolting into motion. You might think it's just your mind playing tricks on you, but there's more to it than that. This isn't just a figment of your imagination. It's a well-documented illusion. So what's the science behind this time-bending trickery? Well, it all comes down to the way our brains process information. When we move our eyes from one point to another, there's a brief moment of blindness. This isn't something we generally notice because our brains are pretty good at filling in the gaps. In the case of the stopped clock illusion, when you first look at the clock, your brain doesn't have any information from the moment your eyes were moving. So it fills in the gap with what you see when your eyes come to rest, the second hand of the clock. As a result, it feels as though the second hand is frozen in time for a split second longer than it should be. Now, isn't that fascinating? It's a reminder that our perception of time isn't as reliable as we might think. It's subject to distortions and illusions shaped by the complex workings of our brain. In essence, time as we perceive it is not absolute. It's subjective, mutable, and ever so slightly magical. Next time you glance at a clock, watch out for this little illusion. Now let's venture into the future. How will our understanding of time evolve? As we step into the dawn of unprecedented technological advancements, our perception of time is poised for a revolution. Let's take quantum computers, for example. These technological marvels, still in their infancy, hold the potential to process information at speeds that make today's fastest supercomputers look like ancient relics. Imagine a world where calculations that would take the most powerful supercomputers thousands of years to complete are done in mere moments. This kind of processing power could allow us to simulate complex systems and phenomena, essentially enabling us to peer into the future. It's a bit like having a crystal ball, but one that's backed by the power of quantum physics. Speaking of quantum physics, it's here that things get really fascinating. You see, ongoing research suggests that at the quantum level, time as we understand it might not even exist. Instead, the universe might operate on principles that are completely independent of time. This mind-bending concept, known as quantum gravity, suggests that the fundamental building blocks of the universe are not particles or waves, but tiny, timeless entities known as loops or strings. If this turns out to be true, it could mean that time is not a fundamental aspect of reality, but rather an emergent phenomenon, a byproduct of other, more basic processes. These are just glimpses of what the future might hold. As technology continues to advance and our understanding of the universe deepens, we may find that our current understanding of time is just the tip of the iceberg. The day might not be far when we look back at our present notions of time as quaint, outdated relics of a bygone era. So where does that leave us? Honestly, we're not entirely sure. The future of time is as uncertain as it is exciting. We're on the cusp of potentially groundbreaking discoveries that could redefine our understanding of reality itself. Only time will tell how our understanding of this mysterious entity will evolve. Time has been our focus today, and we've discovered some truly mind-boggling facts. We started our journey by delving into the Enigma of Time, exploring its relative nature and how it can warp and shift based on our perspective. We then moved on to some astounding facts about time, such as how it can be perceived differently by different species or how it can be manipulated by the speed at which we travel. We also dipped our toes into the mind-bending world of time illusions, where our senses can be tricked into experiencing time in ways that defy logic. Lastly, we looked to the future, pondering the possibilities of time travel and how our understanding of time might evolve. Time, as we've come to see, is far more than a simple linear progression of seconds, minutes, and hours. It's a rich tapestry of complexities and curiosities that never ceases to astonish. Next time you check your watch or phone, remember, time is more than just ticking seconds. It's a fascinating and complex phenomenon that continues to puzzle and amaze us.